Thank you. Good afternoon, everyone. So I'm going to be discussing with you today a one-year project, a case study, if you like, looking at the Lifecycle Sustainability Assessment of shopping bags available at supermarkets in South Africa. So hopefully you've noticed that there's a growing concern over plastics, and a bunch of alternative materials are appearing on our shelves. So if you look at the shopping bags available at your retail supermarkets, you might notice several additions. Aside from the usual Hdpe carrier bags, the polyethylene carrier bags, we're seeing a comeback in the brown craft paper bags. We're also seeing a bunch of other more reusable options. For example, you can see the polypropylene bags, woven polypropylene, which can be used several times. We've got the polyester bags, fibrous polyester bags made from PET recycled bottles. And we're starting to see bioplastics coming in the market. So plastics either produced from bio-based materials or produced from petrochemical materials which are compostable or biodegradable. So briefly, the problem with plastics, obviously we've had a huge consumption in plastics consumption and use. So we're talking about 400 million tons per annum currently, and it's been growing obviously since the Industrial Revolution, if you like. At around about 4% per year, the annual growth, and currently it accounts for about 4 to 8% of our fossil fuel use. So of course plastics are petroleum products and they come from petroleum. The big benefit of plastic is in fact that they're durable. So they're durable and seen as cost effective, easy to process, and of course impervious or impermeable to water and air, which makes them very beneficial for storage and packaging. And this has enabled a whole range of different uses which weren't possible before. But of course, that benefit of being durable is in fact also some of the downfall, if you like, of plastics. Plastics are very persistent. So once used and discarded, they persist in the environment. So plastics might take anything from decades to hundreds or if not thousands of years to degrade, depending on the receiving environment. Obviously, if they're in compost or soil, or floating around in the cold marine environment or underneath a landfill, the degradation is going to differ. But we're talking about really long periods of time for conventional plastics. And essentially the problem is that many of these plastics are single use. So they're not seen as durable products. They're used singly. If you think about takeaway foods, for example, just minutes or hours after we've consumed the product, the food, those plastics are thrown away. So because plastics are accumulating, in fact, the burden on the environment is accumulating. So we're talking about 4,900 million tons globally of plastics that are slowly accumulating in the environment because they're not breaking down. So as I mentioned, the biodegradation of plastic is really slow. Microbes degrade them incredibly slowly, decades, hundreds, if not thousands of years for some plastics. And they do actually break down, but a lot of the breakdown you're seeing is physical breakdown. So they're breaking down into small particles, microplastics or microfibers. And of course, the big concern with these plastics entering the environment is their effect or their impacts on biodiversity and ecosystems. In fact, what we may call plastic pollution. So plastic pollution is obviously how plastics impact terrestrial, aquatic, and marine biota and ecosystems. And in fact, a study not so long ago ranked South Africa as 11th in the world for the mismanagement of plastic waste. And this is calling Department of Environmental Affairs and other agents to think about a ban on single-use plastics. And in fact, many other countries around the world have done that. But we need to think carefully about this problem. So is the problem really with plastics, or is it somehow due to people's behavior? Or is it actually something broader, like our actual waste management system that isn't really appropriate? And if we're not to use plastics, what are the alternatives? What are the suitable alternatives out there which can replace our plastic products? And how do these products actually compare from an environmental perspective, but also actually probably from a social and economic perspective too? So what we're really looking for, what we really need, is some kind of an assessment method or approach which includes the environmental, social, and economic impacts of plastic bags and also the alternatives, in order to inform appropriate and effective decision-making. So Lifecycle Assessment is one such tool. It's obviously based on an ISO standard, and it's most commonly applied solely to the environmental realm. So it's commonly thought of as environmental life cycle assessment. And of course, it considers raw material production, use, or production, manufacture, use, disposal, and end of life, the whole life cycle of the product that we need to consider in this type of assessment. But going beyond the environmental sphere, if we want to do a more holistic type of assessment, we obviously need to include the economic and social spheres as well. So that type of assessment would be called Lifecycle Sustainability Assessment, whereby it actually tries to address the social, the environmental, social, and economic aspects into what would be called life cycle sustainability assessment. So the aim and goals of our work in this project, so we're basically building our capacity within the CSR to carry out life cycle sustainability assessment, and we're building our expertise currently in life cycle assessment and getting to grips with the software. We're currently carrying that out and building our capacity. And we're applying this knowledge or this tool set that we're hoping to build in terms of life cycle sustainability assessment to this particular case study as the outset, looking at different carrier bag options available in South Africa, and hopefully we want to apply this to a range of other products that consumers or industry might be interested in developing to try and inform the decision what's the best choice from a sustainability perspective. So the goal, in fact, of this case study or this project is to compare the performance of different types of carrier bags currently offered by South African retailers in terms of sustainability across the product's life cycle. So if we think about the different alternatives to plastics which might be available, as I mentioned, there's both bio-based and biodegradable plastics. And these are two distinct aspects or characteristics, and they sometimes do overlap, but not necessarily. So if we look here, we can see a bunch of conventional plastics you might be familiar with, Hdpe, Ldpe, polyester, polypropylene, a lot of those petroleum-based bags. They're largely sitting here non-biodegradable and sitting down here petro-based, okay? There's a lot of initiatives to drop in bio-based chemicals and produce plastics which are essentially exactly the same as this, but come from bio-based resources. So one such product on the shelf you might have already seen is the plant bottle, which Valpair are selling their water in and Woolworths are selling their milk, and that is bio-based. It's basically coming from PET, and the ethanol which goes into that PET is coming from sugarcane, so it's coming from a bio-based resource. But it's totally non-biodegradable, just as much as the conventional plastic. On the other side, if you like, when you look at the biodegradables, we've got what you might consider or know as fully biodegradable, for example, our paper, and then we've got some new interesting bioplastic type products coming on the market, for example, polylactic acid or polylactides, which are biodegradable, but somewhat hard to biodegrade. They might need industrial composting conditions. And then there's in fact also several other types of materials which aren't bio-based, but they are in fact biodegradable. So you can get biodegradable materials which come from fossil fuel resources. So there's this clear distinguishment between bio-based and biodegradable resources, and in some cases, such as paper, they're obviously both bio-based and biodegradable, but for others, they're not. So the bottom line is that not all biodegradable bags are in fact bio-based. I mentioned that some of them, for example, can come from fossil fuel resources and are still biodegradable. And not all bio-based bags are in fact biodegradable, or at least easily. So one good example is the polylactic acid, and that really needs good composting conditions, industrial composting conditions. Otherwise, it's quite difficult to break down. So sitting in the cold marine oceans, it's still going to take a considerable long time to break down. It's not readily biodegradable. So as I mentioned, we're comparing these different bag options, and what you may have already noticed is when you carry your shopping in these different bags is that not all bags are the same. So for a start, the bags carry different volumes, and the bags have different weight-bearing capacities. Some are a lot stronger than others and a lot more durable. As you can imagine, the ones designed to be reused many times are, of course, designed to be a lot more durable. So we have to somehow adjust for a functional unit to make sure that we adjust each bag type to make sure that they're assessed in the same way. So the functional unit that we use for a baseline comparison is, of course, our standard shopping bag. So this is our Hdpe, conventional shopping bag, which is single use, although, of course, many people may use it several times or have a secondary use from it. And it's defined as being able to carry groceries from the supermarket to the home with an average capacity in terms of volume of 24 liters and an average weight-bearing capacity of 12 kilograms. And then all the other bag options that we're considering, which are listed here, are those ones which I've highlighted earlier. So we're looking at our polypropylene, polyester bags, and then some of our bioplastics, such as PBS and PBAT, the kraft paper, the LDPE, and some other bag types, for example, the Hdpe ECM, which has got a chemical compound to accelerate the breakdown of that plastic. So all those different bag types need adjusting in terms of their different weight loading capacity and their different volume loading capacity. And once we've done that, they're essentially on an equal footing to make sure that we can compare them. And then we're basically assessing the material flows, all the materials going into manufacturing that bag, which supplies that functional unit, will give us an idea of the impacts associated with that bag's manufacture. So, of course, in life cycle assessment, we normally consider the inputs and outputs into our system or our boundary, which typically consists of extraction of raw materials, transport to the manufacturing plant, production of the shopping bag, transport to the supermarket, use by the customer, eventual disposal, and sending to landfill or littering, waste disposal, basically. So we're thinking about the material, water, and energy inputs and the outputs, which of course give rise to impact categories and damage. And this would be our typical environmental life cycle. So in terms of framing our thinking, obviously you see that a lot of bags have recycled content. So even the Hdpe bags, you'll notice some of them have 100% recycled content. For example, the Checkers bag, in fact, are certified to have 100% recycled content. Others may have varying degrees of recycled content. So recycling is obviously going to help. It's going to retrieve those materials and enable somewhat of a recovery of those materials back. So it's going to save new materials having to be mined or new fossil fuel resources having to be mined. But of course, what happens in recycling is that recycling also comes at a cost. It comes at a cost both financially, but also in terms of water, energy, and materials. So the actual recycling infrastructure is also going to give rise to impacts. So yes, recycling is going to help, but it's also going to give rise to perhaps additional impacts, and it can only recover some, not all of those materials. If, on the other hand, we consider reuse is, in fact, a lot better because reuse completely avoids the need for another bag. We don't need extra energy basically involved in that reuse of that bag, and thereby reuse completely avoids the impacts by substituting the need for a better bag. So people have asked me before, what is the best bag option? And I'm not going to be able to tell you that today because our study isn't in fact concluded. But if I was to tell you, it's probably to try and keep using the bag that you have now, because reuse is in fact one of the best options. So of course, as you're probably aware of in life cycle assessments, we're looking at the outputs from these materials going into our manufacture, our whole life cycle, and those are assessed in terms of impact categories and impact endpoints. So we have a whole range of different impact categories, some of which you might well be quite familiar with, and they're listed here in terms of midpoints, and then what would normally happen is you'd come up with your damage and your endpoints, which would basically give you a measure in terms of total human health, ecosystems or environmental health, and, for example, resource depletion. So there's been a lot of work, in fact, in standardizing these impact assessment methodologies and coming up with databases in life cycle assessment software to make sure that these are basically rigorous and coherent. Of course, the plastic pollution, and I'll come to that a bit more later, isn't one of these impact categories as yet. So that's a notable research gap. But the main point being is that there's a whole range of different impact categories, and we might need to trade some of these off. So one product might be better in terms of a greenhouse gas footprint, a carbon footprint, and the other might be better in terms of impact on water or eutrophication effects. And then if that wasn't difficult enough, that we've got to in fact trade off different impacts associated with a product, environmental impacts, I mentioned we also have to try and integrate the social and economic aspects too. So we're not just considering these environmental type of impacts that you might well be familiar with, but we're also thinking about some social type of indicators that we want to look at in terms of job skills and disamenities. For example, what does plastic litter do to the quality of our beaches, for example, or our recreational resorts? And also the economic aspects. So we need to think about value-adding, economic value-adding, import substitution, and disservices. Do we really want to spend money tidying up waste and doing those kind of services? Is it a real good economic benefit? So those are the type of indicators we also want to include in our life cycle sustainability assessment. So I'm just going to go through very quickly the framework or basically the models that we're going to be utilizing in our life cycle assessment software, going through the different bag options. I mentioned we've got high density polyethylene. That's the thin option of 24 microns. That's our conventional plastic bag. And of course, it's relying on fossil fuel resources as raw materials, and it has got quite a considerable amount of recycling. There's also the thicker Hdpe bag coming in now, so a lot more reusable, also high density polyethylene, but now 17 microns thick, obviously a similar life cycle. We've got a high density polyethylene with an ECM additive. So this is a proprietary additive which has caused a lot of controversy in the United States because it basically accelerates the breakdown to microplastics. It doesn't increase biodegradation, it just helps that plastic break down into microparticles, which may or may not be a good thing. Certainly we don't know what microplastics do largely in terms of environmental impacts, so it could actually be quite a bad thing. But of course, breaking down plastics physically is one of the steps which helps microbes access that plastic resource to accelerate its breakdown. So it may in fact help, but it's a very controversial product, and in fact, I think in the EU it's largely been banned, it's largely been not considered. So then there's the low-density polyethylene, very similar to Hdpe, coming from fossil fuel resources. We've got the woven polypropylene bags, so you might have seen those often with very colorful printed pattern on the front. So again, coming from fossil fuel resources, polypropylene, but it's a woven product, and of course also a recycling stream for polypropylene. We've got the fibrous bags, the polyester bags, spun fiber largely. These are coming from polyester or PET bottles. So in fact, that water bottle or those clear bottles get recycled and get incorporated into those rPET, recycled PET polyester bags. So what's that product life cycle would look like. Then of course we've got the craft paper, the conventional brown paper, that's obviously making quite a comeback, and people are adding sort of waterproofing layers to that to make it more durable. It of course comes not from fossil fuel resources, but from biological resources, from forestry in fact. So it comes from our forestry industry. And of course there, in addition to recycling, it's got another useful end of life, and that would be the composting stream. Then we've got some quite interesting bioplastic options. So we've got PBS or polybutylene succinate, which is being mixed with PBAT. So currently these chemicals are in fact largely coming from petroleum resources, but they are biodegradable. So this is a bioplastic product which is petroleum based but fully biodegradable, and of course it would then have an end-of-life stream as being suitable for composting. Another bioplastic is polylactic acid or PLA. So the first generation PLA will almost certainly come from maize. Maize starch would be the raw material there. And again, since it's compostable and biodegradable, it would have a composting end of life. And I think lastly is polybutylene adiptate terephthalate, PBAT, which is also being mixed in one of the bag options made from HMRP with starch. So we've got a PBAT plus starch mix. So that's quite complicated. The PBAT is coming from a fossil fuel resource, and the starch is obviously coming from a biological resource. Both of them are fully compostable and biodegradable, and therefore the end of life there would have also a suitable composting stream. So we've done some work in terms of looking at the types of impacts in the literature and scoping previous work, and we see that quite amazingly a lot of the impacts depends substantially on the raw materials. So a lot of the carbon footprint, for example, of plastic products such as Hdpe depends substantially on the fact that it comes from ethylene, which originally comes from oil. So 80% of the impacts, in fact, of Hdpe, the carbon impacts, can be attributed to raw material production, basically oil. And this impact is made worse or exacerbated in South Africa, in fact, because a lot of the oil that we use for our plastic, in fact, comes from the Sasol coal-to-liquids process. And that's very energy-intensive and quite a dirty process. So, in fact, it makes our plastics, if you like, our Hdpe, quite a lot more energy-intensive and dirtier than, for example, European plastics, which would be coming from natural gas. So that's something additionally worth to consider. The raw materials, particularly for the petroleum-based products, are going to be responsible for a large portion of the impacts, particularly the carbon impacts. But on the other side of the coin, the bio-based resources aren't totally free of impacts, and we know that, for example, the production of some of those bio-based resources, such as maize, they require land and fertilizer and water, and those are relatively constrained resources in South Africa, and they could also compete with other production, for example, food, because of course maize is used for food. So there could be certain conflicts around food versus plastics, bioplastics, if you like. And of course, those bio-based resources and those farming methods also aren't devoid of impacts. So the carbon emissions as a result of the artificial fertilizer use and the tillage, for example, would or could be quite substantial. So I mentioned that the impacts are obviously strongly influenced by the raw materials, but they also seem to be quite strongly influenced by the end of life, or what happens at disposal of the product. So we've obviously got reuse, recycling, and disposal is what happens at the end of life. And it is, in a circular economy, one would hope that there is in fact no waste, and that every end-of-life product can be reincorporated into some new use. And that would be a real true circular economy. In South Africa, what happens to a large amount of our waste, in fact all our waste just about, in terms of plastics, is it's landfilled. And that's not the current practice in some other countries. For example, in Europe, they incinerate a lot of their wastes and plastics. We choose to landfill ours. But in South Africa, we also know that about only 60% of our wastes are collected. So there's also a large portion of the South African community which don't have their wastes connected. And in addition to that, it's only really the big landfill sites in the metros which are fully compliant. So only about a third of our landfill sites are estimated to be fully compliant with legislation in terms of being managed properly and covered, and also having a liner to prevent leachate. So that's our current status of our waste collection. We don't have a full waste collection service, and we only have a third of our waste landfills compliant. And our recycling rate is also relatively low. Recycling isn't going to save the day completely, as I mentioned earlier. It's definitely going to help. And our currently net recycling rate of plastics is about 16%. So about 16% of our plastics will go into new plastic materials, new recyclates. So some work done by Prof. Harry von Botnitz at UCT has looked at the material flows of plastics in South Africa to try and shed some light on this issue, because there's a lot of controversy going on in terms of waste management and plastics. So we see that in any given year, this is 2017, there's about 1,808 kilotons of plastics flowing in our system or being consumed. Plastic bags, the actual carrier bags, if you like, are about 2.9 billion in 2017. So that's based on the plastic bag levy, and it's actually probably an underestimate because not all plastic bags are levied. There's a big informal industry, if you like, and a lot of plastic bags aren't levied. But at least there's 2.9 billion plastic bags being consumed, which is quite a lot, and that's in fact about 2% of the total plastics consumption in South Africa. So the plastic bag is obviously only a portion of the plastic consumption, but I think quite a significant one. And then also what's quite a surprise is that the actual littering aspect, we get I think an impression that littering is causing a lot of the plastic floating around in the environment. But it seems that the direct littering is only a relatively small portion. Only about 1% of the total plastics ends up being littered. However, there seems to be a lot of leakage coming from the landfill sites. So as I mentioned, only about a third of the landfill sites are adequately managed. So that means 2/3 aren't. And if we do a rough estimate looking at how much plastic is likely to leak or be wind blown into the environment from those managed sites, saying that about 80% of the plastic from self-help sites, so those are people which don't have landfill services and they make their own plan basically, obviously a lot of people in rural settings, about 80% of that leaches into the environment, about 30% from deficient landfills, i.e. landfills which don't fully comply, leaches into the environment, and only about 1% from fully compliant landfills leach into the environment. We get about 25% of the total plastic is currently leaking into the environment, which is of course quite a lot, and it maybe reflects on what we're actually seeing in the environment, which is quite a mess. And in fact, some of the international reports, as I mentioned at the outset, saying that we're about 15th in the world in terms of the mismanagement of plastic. So a lot of the picture is pointing at how we dispose of our plastics and also the management of our landfills and our waste services, and in fact choosing landfill as a disposal option instead of incineration in South Africa. So I mentioned earlier that there's a notable research gap in lifecycle assessment in terms of not having a good understanding of the plastic pollution story. And of course, this is what society is largely concerned about. It's seeing the impacts on wildlife and biota, seeing turtles being strangulated by six-packs and plastic bags, and is becoming really concerned. And that pressure is, pointing towards where's the science behind plastic pollution? How important is plastic pollution compared to all the other type of environmental impacts, like carbon footprint or eutrophication, for example? So there's in fact no established impact method in the LCA software or databases to assess plastic pollution. And this is in fact part of a huge global effort to try and get a better handle on this aspect, plastic pollution. So there's in fact a Mendelean Declaration, basically highlighting the problem with plastic pollution and trying to get a global initiative to focus on that aspect. And you can sign that declaration if you like. I would encourage you to do so. And there's a global MARI LCA, or a Marine Litter Impacts in LCA initiative, which by I think 2020 or 2025 hopes to incorporate marine litter into LCA software, together with the associated databases and impact categories. So in summary, I can basically tell you now that we're going to finish this work at the end of the year and hopefully be able to deliver a coherent picture of which is the most sustainable plastic bag option and why. But at the moment, I can say from scoping the impacts, it looks as though the resource extraction is responsible for a large portion of those impacts. And we're talking about growing maize or sugarcane for those bioplaced plastics, for example, that would carry quite a lot of the impacts, or mining fossil fuels and going from coal to produce oil to produce many of those plastic-type products, and that will carry a lot of the carbon emissions and environmental footprints. And then the other hot spot is at the end of the life cycle, basically the end of life and disposal, where we're looking at our waste management systems, both in terms of collection and also in terms of how to manage those landfill sites better and make sure that they are indeed compliant. So thank you very much.